go to this website, it'll bring you back to our normal Azure Notebooks page, and you'll see a couple of different notebooks there, including one that says Importing and Exporting, which was from last week, and one that says Breaking Out the Dictionary, which is this week's lesson. So if you could go ahead and clone that version, but if you clone that particular library again, and then open up 3, Breaking Out the Dictionary. And while you're doing that, I'll give you a little bit of a preface as to what we're doing today. So, in our previous lessons, and we'll review this as we're going through, we've dealt with the most basic type of text, which is the string, a single block of text. We put that into lists, so we have individual words, or in the case of our in-gram list and our concordance, into blocks of words, 3 words at a time, 5 words at a time, what have you. And we've been able to manipulate that text in so much as we've been able to count how much there's text there is, and we've been able to load it either from a file on our computer or download it from the internet, manipulate it, and very, very briefly, we learned how to save our data back down into our file structure. Now we're going to go through all those steps again today as we're working, but the next thing we're going to be dealing with is a dictionary. Now a dictionary in the language of Python is a very specific file structure. So if you're familiar with lots of different types of file structures, you may be used to XML, which is a file structure that's used for a lot of literature studies and a lot of data collection. And basically XML is a file structure that has an opening and a closing bracket, just like HTML does when you're creating a website with data in the middle. More common in a lot of situations, you'll be dealing with something called a JSON file, JSON. An JSON file is a less hierarchical, more data conservative, so it doesn't use quite so much space way of storing data, and it's something that's really favored by computer scientists, a lot of web applications, and a lot of open data. So data that you get from government organizations will be stored in JSON formats. So if you download a lot of data from social networks as well, social media networks, it often comes in JSON format. So the way that a JSON file is generally speaking structured is as follows. The same way you would think of a dictionary or an encyclopedia, where you have a single key, and then you have a value, such as this. So key and value. And the key can be anything. So it might be name with a value, or it could be age. We're going to go with 21. Value to put next to it. It can be an integer, string, anything you want. And this way, when you're looking up data, you can say, look for the name value and tell me what its value is, as opposed to give me the 7th item in my list and tell me what the value is. You might also want to have nested data. So if, for example, instead of name with a single value like this, you might have within it nested information. So first, melody, and last, feels. And the structure of these is pretty regimented, but once you learn sort of how to parse them visually, you can actually see quite easily that they are very much like a dictionary, value and key. Now what we're going to be dealing with today is we're going to take some of our in-gram lists, our list of words that we created, and we're going to make a dictionary out of them. Now the reason we would do this is pretty simple. If we cut up an entire book into 3-word phrases, a certain phrase might appear multiple times. And we don't want to have 7 or 8 versions of that, we just want to have the one, and then information after it, such as how many times it appeared. This is the simplest form of dictionary I could think of, but you can see how this could be used for any type of database information where you have a field and a value. So, is everybody logged in to that Breaking Out the Dictionary folder? Let's begin. Okay, so first thing we're going to do by reviewing things that we did in the previous two sessions. Namely, we're going to get a data file, we're going to manipulate it, so we clean up the data, make it lowercase, get rid of all of its punctuation, and then chop it up into a nice list of word engrams. Now, I'm going to go through with you with this step by step, and we'll see how much you've been able to remember and how much you're able to employ on your own. So, what you're going to want to do, first of all, is you're going to want to create two different strings, and these strings will allow you to choose which body of text you want to work with at any given time. The first one is going to be A Tale of Two Cities, which was that text file that we downloaded previously and is already in that directory. So that's practicing loading up a file into a string. And the other one is going to be a book from Gutenberg. Now you can use any Gutenberg book you like. I recommend this one considering the season at hand. So what I would like you to do is to create two different strings. You can name them whatever you want, but assign them with different data. So the first one we're going to want to do is to assign the Tale of Two Cities data to a string. So why don't you work me through this? What's the first thing that we need to do if we're going to assign data to a string? So it's that formula that's right there on the screen. So with open, the name of the file, and then R, because remember R is for read, as file, and then the colon. Remember, you need that colon there. And then data, what does data represent? What type of thing is it?
Yeah, variable.
Variable, absolutely. So it's the name of your variable, you can call it whatever you want. And then file.read. And read is the function that's being read on the file. So remember, file and file have to be the same thing. You can name it whatever you want, but it needs to be the same. But file name.text needs to be that Tale of Two Cities text that we've done already. So go ahead and in your box, type in this small function in order to read that file into a string. So I'm going to call it tale. With open, Tale of Two Cities.text as read, as file, tale equals file.read, and in parentheses. And that is going to give me all of that file into the string tale. Now, I want to do this with a different one that I'm going to get from the internet. So what you'll need to do is you'll need to use this other function that we discussed here. So remember, import request. So what does import request do? It is, absolutely. Import request is importing the requests library, a bunch of functions that have already been created for us to use. Then data equals request get and a URL. So what is that doing? It is, absolutely. And then what about this last one? Data equals data.text. So this one here is putting all of this data into this variable called data. But it's storing it in sort of a compressed fashion. We have to tell it that it's text. So by saying data.text, we're changing that data from a package into just plain text. Now for the sake of just keeping the number of variables small, have just renamed it data as well. But you can make it a new variable if you want to keep them separate. So go ahead and import requests, import whatever Gutenberg book you like, and then convert that package into text data. And once you've done those two things, once you've opened the text file that's on your hard drive and opened the text file from the internet, go ahead and print the first 500 characters of each of those just to make sure that it's done correctly. All right, so you now have two strings. One string has A Tale of Two Cities, and one, if you didn't change it, now has volume 2 of Edgar Allan Poe's collected spooky stories. So, what are we going to do with these two things? Well, we're going to continue on in the same way we have previously by cleaning the data. So remember, cleaning the data has several steps. If you were doing this for your own project, you would be able to clean it in however worked best for your project. But we're going to do some very simple ones here just for the purposes of concordance. And the way we're going to do this is first, we're going to remove punctuation, and second, we're going to make it lowercase. So let's go through these functions real quick together before we implement them. The first, import re, again, regex, or regular expressions. And then my string equals r sub, resub rather, this regular expression and this. So just to remind you, my string, you don't have to call it my string, it's your new cleaned up data version. So tail clean or spooky clean, whatever you want to call it. Reg sub is the function, and this first little bit before the comma tells it to remove everything that's not a word and everything that's not a space. So caret / w, caret / s, everything not a word, not a space, and that asterisk means even if there's more than one of it. These two speech marks together with nothing in between it means that you're replacing everything that's not a word or a space with nothing, so you're just removing all the punctuation. And data is the name of your data, so replace that with tail or spooky. Now you don't have to do this with both strings, just do whichever one you want to work with. So if you want to work with Dickens, or you want to work with Poe, whichever you feel most comfortable with. So go ahead and essentially copy this, changing data to whichever of the two strings you want to work with. And once you've done that, go ahead and reassign my string, or whatever you named it here, and do that full stop lower, and that'll make it all lowercase. So if you do these 3 lines, you should have a string, and you can test it through a print command if you like, that has no punctuation and is all in lowercase. To reiterate, import the regex library, create a new string where we do our regex function on our spooky or our tail, and then do the lowercase function on that same string, and we get a version that has no punctuation or text. And I will come around and help those who need it in just a moment, but just to move on to the next step for you guys. What we need to do now is to remove those headers. And if you noticed, they all have the same header, which is this is a product of the Gutenberg library, please redistribute but don't steal, that sort of thing. We don't want those to add to our word counts because those are going to be the same in every Gutenberg book and they're not actually part of the text. So I've created this little bit of text here. This function here looks for a function called mystring.find, and what find does is it finds what is the character that something starts with. So I'm looking for start of this Project Gutenberg ebook. That's in every single Gutenberg ebook. And it looks for where in my string, or whatever you've named your string, that is. And it finds that number. And I've labeled that start. And I do that with the same thing with end of this Project Gutenberg ebook. Looks through the whole string for that bit of text and tells me where that starts. Then, what is this last bit doing here? Can anyone tell me? So what I'm doing, this function here is that same function you always use to do the first 500 characters or the last 500 characters. And I'm telling it, instead of starting at 0, like we normally do, I'm saying start at this number plus 37, which is how many characters this is. And end, instead of at the end at this character minus 35. So again, it's going back that many characters. So it'll remove that whole chunk from the text and just be the middle part of the string that remains. So go ahead, all you have to do is change my string to whatever you actually named your variable and run that. And I'll go around and catch up with everyone. So we should all have, or be very near to having, a string that is all in lowercase, that has its headers removed, and it's just the text we want to work with. Congratulations, you have cleaned data. According to most estimates, cleaning data takes 80% of any project. So the rest of this should be easy. Now what we're going to be doing is creating the dictionary itself. Now there's a lot of text here, and this is just to remind you when you come back to this file later what I'm doing. A dictionary is a special sort of list that has a key and an entry, as I mentioned before. Another way of thinking of it is that you have a big stack of index cards. And each index card has a key in the corner, has a word, and then some data on that index card. And what a dictionary is a box you stick all those cards in. So you can just search through it, look for that key on the corner, pull it out, I am showing my age, and find that information on the card. So what we want to do is to split our word list, our string, into a list. Because that's how you make a dictionary, is you need to start with a list. So we all sort of remember that to make a string into a list, you use what was the name of the function? Split, yes. I'm sure none of you are cheating by looking at this page. So I've created a little file program here. This is exactly what we did last week that we had a session to create this concordance program. I've just written it out here so that you don't have to write it out. But I will go through it with you really quickly so that you can remember what all the steps are. So the first thing we're doing is my string, and you will have to change this if your cleaned up string is a different name. So my string and split into my words. So we now have a file, a list of words called my words with everything split up. Then we create a new list, which is what these square brackets are, an empty list. And that list is going to be where we stick all of our engrams. An engram, again, is just a certain number of words, a 3 gram, a 2 gram, a 7 gram, whatever you want. And we have an I equals 1. What does the I represent? It's an iterator. It's iterating. It's going through it once, twice, 3, 4 times. So this little while loop says, while I is less than len of my words. What is len of my words? So while the word that you're on is less than the total number of words, keep going. And if the word that you're on is less than the total words minus 1, and this is basically so that you don't end up with just the 1 and the 2 words at the end. It'll stop when you always have at least 3 words to make a list out of. So that's all that line does. Ngram equals this function. Does anyone remember what this little join function is doing? So it's joining together with spaces. So join with spaces in speech marks. The word before the word you're on to the word after you're on. And the reason it's +2 is because the second number in that little bracket tells you the first word you're not using. It's the first word of the part you snipped off. So -1 to +2 is the 3 words surrounding your word. And then it takes that engram that you just created and sticks it onto your engram list. It appends it onto that blank engram list. So basically it's going through every single word in your word list, taking the word before and after and making a nice little package, and then sticking that in a brand new list called engram list. And it does that one word at a time. So it was the best of, if you're doing, I can remember that much of the book, and puts that all into a big list. And what does this little bit at the end do? Starts it again with the next word. Yes, so it makes I the next number up. So go ahead and change my string to whatever you named your cleaned up string. Most of you probably left it my string, but rename it if you want to. And then run this program. It will not print anything, but it should run and say that it's completed. So we have printed our engram list. We now have a list to build our dictionary out of. Now, the next bit is going to be a lot of talking to explain things, and then the actual code is very, very tiny. So, a lot of talking, small bit of programming. So, if I bring it down here a little bit to show you. Now, we are going to make a dictionary, and we're going to call it count, for whatever spooky reason you want to believe. And when you make an empty dictionary, you use curly brackets. So if it's a string, it's in quotation marks. If it's a list, it's in square brackets. And if it's a dictionary, it's in curly brackets. So the brackets that go in and out again like that. Not just round ones, squiggly ones. Okay, so that's a very simple one. And you can just go ahead and run that cell that already has count in there. And that is your empty dictionary. Nothing in it, just the book cover. Now, every time you want to add something to your dictionary, it has 2 components. It has a key, so what that value is going to be called, what that item is going to be called, and then it has a value, whatever you've assigned to that particular field. So again, Name is the key, melody is the value. Now, it's really very simple. So if you wanted to, and then what we want to do for this particular dictionary is we want to go through every word n-gram in our n-gram list. And if it doesn't exist in our dictionary, we want to add it to our dictionary and say 1. And if it already exists in our dictionary, we want it to just iterate up 1. We just want to change that 1 to a 2 or that 2 to a 3 and go through it like that. Does that make sense to everybody? So we're just going to go through and say, yeah, oh, add 1, like that. So, if we wanted to just add 1 to a number, we all remember arithmetically how to do that. So if our variable is 6, and we want to add 1, we would just do variable equals variable plus 1. So if variable was already equal to 6, it would suddenly become 7. Really basic math that we did the first week. Everyone following? Okay. This is a lot of steps put together logically so that this makes sense at the end. So, how do you create a value in a dictionary in the first place, though? So you don't just want to update it, you want to actually create it. Well, if you want to do something in a dictionary, you do it like this. So the name of your dictionary, so for example, count, and then in brackets, you put the key name. So if it were a dictionary people, it would be people and in brackets name. So you're looking for the name value. And then equals, and then put whatever you want there. So people, name, melody. That's how you would add it normally. So if you want to do that for a new value, you do it the same way. And if there isn't a key name that already exists, it'll just create one for you automatically. So if there is nothing in your dictionary with that name, it creates a new one. If there is already something with that name, it will replace the value with your new value. Does that make sense to everybody? So this little function will either create a new value or it will replace the value of that name. Okay, so if you wanted, so again, count n-gram equals 0. So count is the name of our dictionary, n-gram is whatever set of words that we're finding in that dictionary, and then we're setting the value to a certain number, 0 or 1. But if we did this every time, so we made a little for loop and said for every n-gram in our n-gram list, do that, it would always reset it back to 0. We would never get anywhere with it. So you have to explain to it that you want it to take the value it already has and add 1 to it instead. So you have to use this little function right here, which is x.get and then a y and z separated by a comma. Now, first, what this does is it checks to see that the key y exists. So, y is the name of whatever you're going to use, so the n-gram you're looking for. If it doesn't exist, it will create it with whatever value you put as z. And x here is just the name of your dictionary. So if I'm looking for people.get, in brackets, name, comma, melody, it'll look for a name. If there isn't a name there, it'll fill it with melody. So that's a pretty easy way of finding it. So if we want to fill with 0, if it doesn't exist, we put n-gram, comma, 0. But because this works just like any other function, this will give you a value. So this will return a number, basically, if it already has a value. So if the value is already 7, this little function will give you that 7. So if you already have the value and it's 7, how do you make it 8? Plus 1, yeah. It's pretty simple. So, in this little box, and I will come around to help you, I want you to create a for loop. And that for loop, so for something in something, and you can look above if you want to have an example of it, go through every n-gram in your n-gram list. So how do we do that? What would you type? So you have completed bullet point 1. You've created a for loop that goes through your entire n-gram list. Now, I want it to create an entry in my dictionary with a value of 0 if it doesn't exist, or to add 1 to my value if it does exist. So how would we go about writing that? Count, very good. Then what? Perfect, in-gram square brackets. Okay, so what are we doing with this? We're assigning a value to this in-gram. So equals. So how do we tell it what number to assign to it? So if we do equals 0, that's just going to set this in-gram to 0. And that works fine if it's the first time through, but we want to check first if it's already set to 0. So what function do we use to find out what the value is? So how do we type that out? That's all it is. That's how you make a dictionary out of it. You tell it to go through every in-gram in your in-gram list, and for each in-gram in your dictionary, find out if it's already in your dictionary, and if it's not, make it equal to 0. If it is, add 1 to it. And the best way that you can do this is the same as for everything else. You can print count, and again, just do the first 10 so that you can see how well it works. And as you can see, is composed the has a value of 2, in character from has a value of 2, so these are all the different dictionary entries. You can sort of see now how the structure of a dictionary is formed. This is the same structure you will see for JSON files. If you ever get any data from social media, from government databases, from lots of online archives. If you want to work with tabular data, data that has a value attached to a certain name, this is the format. And you'll be able to upload those into your Python programs the same way you did with the text file, and sort of skip all those first steps and just run things on your dictionary. So, this is a very simple dictionary. It tells me how often certain 3-word phrases appear within a text. It's not the most useful bit of research, but it gives you an idea of the sort of thing that you can do. Now that you have that basic idea of how to make a dictionary, we can do something a little bit more exciting for our last 5 minutes. Now, that was in order. That was basically all the different in-grams in the order they appeared in the text. And you saw a couple that were 2, and you're sort of like, 2, that's not very helpful. But actually, hidden within the depths of these texts, there are actually some very common phrases that would be quite interesting to see if you were, for example, doing author attribution or looking for style or genre. So, what we want to do is we want to sort this dictionary. We want to put it in order. Now, there are lots of different ways to do this. Basically, any way that you would do it manually with your index cards, you can do it with the computer. This is a way that I thought of doing it, so we're going to try it that way. So, what we're going to do is we're going to do another for loop. And that for loop is going to, when you're using a dictionary, it's a slightly different way of phrasing it than you do it for a list. And that's because it's got the 2 different values. So you can't just say for every item in the list because it has 2 values. It doesn't know which one you mean. So what you would do for a dictionary is for in-gram tally in count.items brackets. And what this basically means is in-gram and tally is the key and the value. I've named it in-gram and tally, but it could be any words you want to use. They're just sort of placeholder words. You just have to remember what they are and what they represent. First one is the key, second one is the value. Count is the name of your dictionary, and .items is the function itself. You can't change that. It has to be .items. And what that basically means is, okay, I'm looking for keys and values. Just telling Python to do that. And on the second line of your for loop, you can tell it to do something. So, what I would like you to do is to create a while loop. So one of those loops that uses the I iterator to move instead of the for loop. And I would like you to go backwards from 100. So I equals 100 instead of normal, I equals 0. And at the end of your while loop, you do I equals I minus 1. So it goes 100, 99, 98, 97. And then what you'll do dictionary have 99 copies of it? No. 98. Does anything have 98 versions of it? And if it does, then have it do something. And in this case, print it out. So let's work through this together. So, first, let's create the skeleton of our while loop.
So what we begin with is the iterator, I equals 100. Now remember, we're starting at 100 and we're counting down to 0. So we start at 100. Then we create the skeleton of our while loop. While I is greater than 0, counting down to 0. And then at the bottom, I equals I minus 1. So every time it goes through the loop, it subtracts 1 from I, 99, 98, and so on. Now let's do our for loop inside of our while loop. Now this is to go through every entry in our dictionary. So using that formula we talked about earlier, for in-gram tally pair, in count, using the function items. So for every in-gram and tally pair, ask this question, if tally equals I. So what is this doing? Well, basically what it is saying is that as we go through every number from 100 down to 0, and then within each number, we go through every n-gram in our dictionary. And if the tally of that particular n-gram is the same number as the I of the while loop, so if we have number 74, and we go through every word and we find a word combination that has a tally of 74, so if tally equals two equal signs to ask a question, I, then do something. And in this case, we just ask it to print. And what we're asking it to print is the n-gram, followed by a colon and a space, followed by the tally. Now the tally here is recast or changed into a string using the str and brackets around tally. And the reason we do that is simply because you can't have a print command with a string and an integer, and that's what the tally is. It's an integer or a number. So we have to convert that or cast that as a string before we continue. So, just to review, our while loop is counting down from 100 down to 0. Inside of that we have a for loop going through every single n-gram, so it goes through this n-gram tally list 100 times, one for each I, and if the tally is the same as the I it happens to be on, it prints the n-gram and its tally. And as you can see here, when we run this program, it prints all the different n-grams in order, starting from the highest tally to the lowest tally. If you continue on with this worksheet on GitHub, you'll find a couple more exercises to help you get the hang of dictionaries. I hope you enjoyed this lesson, and I look forward to talking with you again next week.